All right, there's a quantity for IV that you have to know that is something called the angular magnification. This is different than the linear magnification that we had before, where we could just take negative di over do. This is a bit more how an object is perceived overall. And if you look, the magnification, angular magnification gets the big letter M, and it says it's the angle subtended by by image at the eye, or the angle subtended by the object at the unaided eye. So I've got a drawing, or at least a couple drawings here, where let's say the object was at the near point, the distance at which the eye can focus comfortably. Any closer than that, and it wouldn't be. 25 centimeters away. The eye, okay, we would perceive a certain height, and the distance along an axis drawn to the eye and a line to the top of the image would form this angle. That angle they call alpha, okay? And if we actually wanted to find it, we'd have to do a function of HO over 25. We're just using some trig, okay? We'd have the opposite and adjacent sides. We'd end up using tangent to find that particular angle. The other circumstance would be as if that image were, say, a really, really, really long ways away. Well, if an object was at infinity, okay, then the image, if we put a lens in front of your eye, would form at the focal length of that lens, okay? Therefore, that object is going to appear to be a different height, and it would form at the focal length from the lens. So if your eye was right there, along that axis again, we would form a different angle between the axes and the actual height of the object. That particular angle they've marked as being beta. Now if you look at that one, okay, the distance that it's away then is f, okay, and its height again is ho. So they have the a generic form of that equation just saying ho over f, okay? So oftentimes the magnification at infinity, being beta over alpha, is ho over f times 25 over ho. Well, the ho's would go away, and the magnification is simply the near point divided by the focal length. Now, it's normally 25, but in equation form, it's often seen as just the letter d. Okay, I don't know why they picked d, but that's usually what it is. Okay, but that's for the image at infinity. Okay, now the derivation for the image at near point is a little it's a little hard to follow at times. So I'm just going to tell you that for an image at the near point, okay, it's exactly the same except you add 1 in front of it. Okay, so you're going to see both of these particular equations in your packet. I just want you to know that this particular one, it's going to be d over f equals m, is at infinity, and if it's at the near point, you have to have a 1 in front of it. Okay?